Hello dear students, I'm recording this video after completing this course, and the title of this course is the Vector Calculus, which can also be called as Vector Analysis or the Calculus 3. There are four main chapters that are covered in this course. The first one is the Introduction to Line Integrals, the second one is the Introduction to the Surface Integrals, and the third one is the Integral Theorems, which includes the Green's Theorem, Stokes' Theorem, and the Divergence Theorem, which are very important theorems that are extensively used in different disciplines of mathematics and engineering fields. The fourth chapter is the application of these theorems. Let me talk about the main topics that we will discuss in these chapters. In the first chapter, which is the introduction to the line integrals, we will learn in the initial few lectures the mathematical definition of the line integral of scalar fields and the vector fields, and the geometrical interpretation of the line integrals. And we will also discuss some basic concepts from calculus, for example, the fundamental theorem of calculus and the smooth curves, piecewise smooth curves, and tangent to the curve, etc. And then we will learn how to evaluate the line integrals of the vector fields and scalar fields. And then we will learn that how the work done is expressed as a line integral of a vector field. This is a very important topic, and this is very basic notion from mechanics. And then we will learn the path independent line integrals. The line integrals usually depend on the path of integration and on the endpoints of the path of integration also. But there are some line integrals that do not depend on the path of integration, they just depend on the endpoints. And we will learn such integrals in this topic. And then we will state and prove four important theorems on path independence. And using these theorems, we will learn that how we can evaluate the path independent line integrals more easily. And then we will learn that what are the conservative fields, and this is also an important notion from mechanics, and how to find the scalar potential for the conservative fields. Okay, this is very important topic. And then we will state and prove the law of conservation of energy, and this will be our theorem number 5 of this chapter. And then we will discuss the applications of the line integrals. The first application is to find the area of a fence whose base is the given curve. And the second application is to find the total mass of the wire having shape of the given curve. And the third application is to calculate the center of mass of a wire having shape of the given curve. More than 30 examples are worked in order to understand these topics, and these examples start from very simple and straightforward questions, and the level of difficulty increases as we proceed forward. And I have also included more than 40 practice assignments for you in this chapter. Now we will move to the second chapter. The chapter number 2 is Introduction to the Surface Integrals, and this chapter starts from the introduction to the double integrals, because you cannot solve the surface integrals unless you are good at solving the double integrals. In the initial few lectures of this chapter, we will discuss the graphical interpretation of the double integrals, which gives us the first application to the double integrals, and then we will learn how to evaluate the double integrals, and then we will learn how to change the variables in the double integrals. And then we will discuss the applications of the double integrals. The first application arises from the graphical interpretation of the double integrals, and it is the calculation of the cylindrical volume below a surface. And the second application is to calculate the mass and the center of mass of a two-dimensional object or a lamina. And the third application is to calculate the moment of inertia of such a lamina. And then we will discuss the parametric representation of a surface and the coordinate curves on a surface. And then we will discuss how we can find out the area of a surface described parametrically, and we will also discuss alternative formulas in calculating the area of a surface. And then we will discuss how we can find out the expressions for the tangent plane and the normal to a surface described parametrically. This is very important topic. And then we will discuss the orientable and non-orientable surfaces and piecewise smooth surfaces. After learning all these topics, you will be in position to understand the definition of the surface integrals of scalar and vector fields and how to solve them. More than 35 examples are solved in this chapter in order to understand these topics, and more than 50 practice assignments are included. Let me move to the third chapter. The third chapter is the integral theorems, which is the most important chapter of this course. The first theorem that we will state and prove in this chapter is the Green's theorem in plane, which converts a line integral into the double integral. And we will use this theorem in solving the line integrals. A difficult looking line integral can be converted into a simple double integral using the Green's theorem. And we will do this in the examples corresponding to this topic. And then we will state and prove the second theorem of this chapter, which is the Stokes theorem, a very important theorem that converts a given surface integral into the line integral. And we will also learn how we can verify this theorem using an example. This example will be quite important and a little bit difficult. And then we will learn what is the connection of Stokes theorem to the path independent line integrals. Actually, in this topic we will prove the converse of the theorem number 4 of chapter number 1. And then we will learn how we can calculate the triple integrals. The triple integrals are necessary to discuss because in the next topic we are going to state and prove the third theorem of this chapter, which is the divergence theorem that requires the knowledge of triple integrals. And this is the divergence theorem of Gauss. And we will learn how we can verify this theorem using an example. Only more than 10 examples are included in this chapter because this chapter is mostly theoretical, and more than 20 practice assignments are included. Let me move to the fourth chapter. The chapter number 4 is the applications of the integral theorems that we have studied and proved in the chapter number 3. The first application that we will discuss is the derivation of continuity equation that we study in the course of basic fluid mechanics. And the technique that we will use to derive this equation is called the integral approach, and this equation is also called the law of conservation of mass. And the second equation that we will derive is the heat equation that is studied in the basic course of partial differential equations. And then we will derive the Green's first and second formulas. So this will be our chapter number 4, and further topics will be added in this chapter, and further examples will also be included in this course and also on the demand of the students. I hope the students will like and learn from this course. Thank you.